All right, so we're going to go over one more example of fully factoring a polynomial, and then we'll move on to an introduction of the next topic. All right, let me just pick a good one here. Okay, so here we have the function 2x to the fourth plus 5x cubed plus 4x squared plus 5x plus 2. All right, so you're going to do this in steps. All right, so the way I have it set up, the first thing you're going to do is you're going to find your possible rational roots. All right, so I'll give you a quick reminder. That is your PQ. All right, well, this one, we don't have many choices. My leading coefficient is 2, and my constant term is 2. So both have a factor of 1 and 2. All right, so we just have to make combinations and make sure they don't repeat. So we have plus or minus 1, plus or minus 2, and then we have 1 over 2, so plus or minus 1/2. And then we have 2 over 2, which is 1, so we don't have to repeat that. All right, so we got 6 possible zeros. So again, for most of this class, I'm not going to tell you to not use a calculator. All right, so you will have access to calculators or graphing utilities or whatever it may be. So your next step is to graph this, which I will do right now. All right, so here we have our function 2x to the fourth, blah, blah, blah. So again, so one thing you tell yourself is, all right, it's to the fourth power. So it could have 4 possible zeros, real zeros, all right? It will have 4 factors, okay, 4 linear factors. Looking at the graph, okay, if we zoom in, well, there's one definitely at -2, and it looks like there's one, yep, there at -1/2. All right, so looking at the graph, you have 2 real zeros, okay, at -2 and 1/2. Oops. So your next step would be either, I forgot how I asked it, if I asked for the zeros or if I asked for the factors, but we'll do both. Okay, is to do synthetic division, right? So like I said, always try to make it easier for yourself. So pick the easier starting one. All right, so I'm not going to try 1/2 yet, especially because I have 5 up here, and I don't want to deal with 5 halves and things like that. I'm going to start with -2. All right, so again, remember when you're doing your coefficients for this, just be careful you're not missing any terms, right? If this wasn't here, it would be 2, 5, 0, 5, 2, right? If you're missing, an x cubed, x squared, or an x, don't forget to have a 0 as a placeholder. We do our synthetic division. -4, 1, 2, 2, -4, 1, -2, 0. Okay. So now you could go ahead and you can, after your first one, okay, you're going to have a few options on how to proceed. So what I'm going to do real quick is I'm just going to rewrite this. Right. So remember, when x equals -2, that tells me my factor is x plus 2. Right. So I have x plus 2 as a factor. I took that out, and I have left over 2x to the third plus x squared plus 2x plus 1. Hold on 1 second. Let me double check something. Okay, no. I wanted to make sure I wasn't going over the problem I gave you for homework. All right, so now that you're here, you could go ahead and you can try this, right? But here we have a cubic function with 4 terms. So when you see that, and especially when you're looking at the coefficients and they look like they're kind of in pairs there, we're going to do factor by grouping. Right, so we take a look at the first 2 terms and the second 2 terms. Right, and I'm going to kind of forget about this x plus 2 right now. It's not going to go anywhere. I'm just not focused on it. So when we rewrite it later, I just have to remember to add that with it. So here, okay, between the 2x to the third and an x squared, we're looking for common factors. So both of them have x's, and both of them actually have x squareds in them, right? There's an x squared in here. So I pull out that x squared. What do we have left over if we pull out an x squared? 2x there. What do I have left over when I factor out an x squared? Well, that's just going to be 1. Now here, okay, so this is one of the reasons I wanted to show you this. Here, there's no common factor. Okay, there's nothing I can pull out of a 2x or a 1 without creating some weird fractions. So when that happens, what you're just going to do is you're just going to put a 1 outside of your parentheses there. Okay, because you can factor out as many 1s as you'd like, right? This could be 1 times 1 times 1 times 1 times 1 times 2x plus 1, and it would be the same thing. So now our factor by grouping tells us we're going to take out this term because it's shared in both. And what do we have left over when we remove these? We have x squared plus 1, right? The x squared plus 1. Now, here I'm just bringing this down. It's coming along for the ride. So these are all of our real factors. Okay, these two are linear. This one gets me that -2 that we had. This one, when we solve this, it gets me that -1/2, that other one that we had. Right? Now this one, in terms of real numbers, I can't take this any farther. Okay? I can't, there's no real number that goes in there. Now remember, there's 2 ways to do this. When it's just an x squared and plus a number, a constant, then you can set it equal to 0 and solve. Okay? If it was a full quadratic, like x squared plus 5x plus 1, then you would have to use your quadratic formula, -b plus or minus, all that fun stuff. All right? So here, again, just be careful. All right? When you're doing this, you're going to subtract 1 from both sides. When you take the square root, plus or minus, so here they cancel out. Well, here all we have is the square root of -1, and that's I. All right, so there we have all of our solutions. X plus 2 gives us x negative 2, x equals negative 2. 2x plus 1 gets us x equals negative 1/2. And then this, we get our two imaginary solutions, positive I and negative I. Right. So just in case they want the full factors, okay, these would stay the same. This one, you would just have x plus I and x minus I. All right, so these are your solutions, and these are your linear factors. I forget how I asked it. Let me see. Okay, all I ask for are the zeros. So you just have to give me this stuff. Okay, so that's what the homework's going to be on. That's going to be due next Monday. Any questions? All right, so with the remaining half of class, I'm going to introduce the next topic, rational functions. All right, so what are rational functions? Rational functions are functions that are divisions of polynomials, okay? Or a more formal term is a quotient of polynomial functions. So we have n of x, which is our numerator function, over d of x, which is our denominator function, right? And if you have a situation like that, then that is a rational function, right? And as always, we can never have 0 in the denominator, so your denominator function can't be the 0 function. So with that comes a big part of our rational functions, okay? I don't want to start this. All right, so let's talk about the domain. All right, so let's consider our most basic rational function, 1 over x. What is our restriction here? What is the one thing that x cannot be? Right, x cannot be 0. So there's a few ways that we can say that if we're talking about the domain. You can just say x doesn't equal 0. Okay, that's one thing, right? If we're doing interval notation, okay, I would say that the function goes from -infinity to 0, and then it skips 0 and goes to positive infinity. Let's take a look at what happens near 0. All right, so let's bring up our graph. Did I get rid of it? Nope. All right, so as we get closer to 0, some funky things happen. So as I approach 0 from different ways, different things happen. So here, if I'm reading the graph left to right, well, I start off really close to the x-axis, right? A very small decimal, -0.1. So here I'm getting more and more negative. My numbers are getting larger. And all of a sudden it just jumps. Okay, so it goes, here up into this point, we're not even above or below -1. Okay, and then once we cross this threshold, it just jumps. Right, and if I keep going down and I zoom in, we can see that it will never touch the y-axis here. Okay, it doesn't matter how close I get, that x number, okay, we'll never touch that because we can't equal 0, right? This y-axis is when x equals 0, so that's impossible. Oh, let me zoom back out, that'd be easier. Now, once we skip over 0, and I start, I plug in 0.001 or here 0.036, I'm at the opposite end of my y values. I'm all the way at the top. I can't even get up there. Right? So here I'm at 47.38. And then I fall down again and I come close and close. Right? So those two aspects, kind of the vertical boundary line and this horizontal boundary line, are key features in rational functions. They are called asymptotes. Okay. So every rational function will have at least one vertical asymptote, all right? And that is found from the domain. So going back to when we did, what was it? End behavior. Okay. We talked about as x goes to infinity, f of x goes to infinity, stuff like that. So now here, how do I want to say this? Okay, so this is tying a little calculus in. So this is saying as x approaches 0, and now you're going to see a little plus or minus up here. And what that means is, are we approaching from the left or for the right? Now be careful. It can be a little confusing. So let me draw a quick graph here. So as x approaches 0 from the left, so that doesn't mean I'm looking this way because it's on the left. I'm approaching 0. So here's my x equals 0. I'm approaching it from the left side. So I'm moving to the right from the left side. Okay, so in this case, as x approaches 0 from the left, my function f of x is approaching positive infinity. We're going up. Okay, and that's one of the key components of an asymptote. Your function will approach infinity. Okay. Now, on the opposite spectrum, as x approaches 0 from the right, okay, my function f of x will approach negative infinity. Did I swap that? I think I swapped that. Yep, I did. My mistake. Well, let's just do another example then. So this would actually be the inverse, -1/x. So sorry about that. Let's talk about what we were talking about. Okay, so this is what the real graph looks like. My mistake. But again, all that does is it changes my approach, right? Here, as I'm approaching 0 from the left, all right, now I'm approaching negative infinity. As x approaches 0 from the right, my function will approach positive infinity. All right, so where that happens, though, this number might change depending on what our function is. Okay, now how we find that is actually pretty easy, and that'll be, actually, no, I'm going to save that. All right, so we'll finish here today, just with the very basics of our rational functions, and we'll pick it up tomorrow. All right, guys. So the assignment for the real and complex zeros, that's already up there, so you can get started as soon as possible. The sooner you finish, the less you have to worry about, especially over Thanksgiving break. It is due next Monday. All right. So yeah, get that done as soon as possible. All right, guys. If you don't have any other questions, that's it for us today. Have a nice day, and I will see you tomorrow.